Spicy.
What's the word? Spicy. Okay, we're gonna talk about the mill now. So, yeah, this is what the mill looks like. It's pretty cool. So this is the vise.
What's the mill used for?
The mill is to make, basically, if you need something that isn't a circle or isn't round, and you need to have holes or make it like you need to have holes in really precise locations, or you need to have it be a really precise thickness. This is the tool to do all of that. This is what was made on a mill at some point, out of aluminum. So don't drop this on your phone. It's really heavy. It's a block of like solid aluminum.
So you'll notice this is done on a.
That's what I put on
a CNC mill.
Yeah.
I cast
but
something
like the edges, okay, are really square.
Nice and flat and
Notice
happy.
that the holes are in an exact location where they need to be diameter, exactly the right diameter. You'll see that there's the numbers and the letters and stuff are all kind of cut out. That's what you can do with a mill. You wouldn't be able to do that with
a drill press
and
handsaw. My hand drill is going.
So kind of
just like grind it in.
Precision is the name of the game, and as we go through the other pieces of what we'll emphasize that a little bit more.
There's like 3 levels of precision: hand drill press, mill. Mill being the most.
So if you really need a precise cut or precise, basic what piece.
This is if you need to be perfect.
Yeah, you would use the mill. Okay. So that's his main purpose. So Tyler's what he's going to do is he's going to walk us through.
Tell you the parts that are important.
Well, let's walk through what it would be like if you're walking up to the machine. What things are you looking for before you put your piece of metal in there, and then how you go about clamping the metal in place, and then
okay. So you start out. Here's your vise. This is where you put your metal. It's basically. Where'd my clamp go? There it is.
Just bring it all over here.
Where did this wood come from? So it's essentially a giant clamp. You put your thing in it, and then you tighten it until it doesn't come out. That actually hurts.
This is the vise, okay?
This is the vise.
Instead of kind of pumping it the way Tyler did.
You rotate this little wheel, and it will make it really, really happy. And I'm not going to say
so that's the
yesterday.
That's the vise.
This is the vise handle. Vise screw, vise, something like that. Something to do with the vise, but that is the vise.
Yeah.
That tightens it. Okay. So then I would take my bit and my chuck and use the auto chuck control switch to chuck it into the mill, I guess.
Yeah.
So basically, this device allows you to, if you didn't have this, basically you'd have to go up here, all the way up here, and take a wrench and wrench this thing around to pull it in. Apparently people at the shop got tired of that, so they got this pneumatic device that just spins it really fast. And therefore, you can't, it doesn't, so it's like a second to just chuck it in and out. One of these says in, one of these says out. It's kind of blurry. So I can't tell.
So why do you care about the chuck, Well, the chuck is what holds the bit, and the bit is what actually has their sharp edges on it and do all the work, okay? And there's bits that have pointy ends like you have on like a drill, okay? Plunging.
Plunging, which is going
like this,
down.
like that, all right? And then there's ones that have kind of flat ends.
For like scraping off the top.
Yeah, a piece of work you could be kind of going across it like this, okay? And so if you have a mill bit or whatever that has a flat end, don't try to plunge, okay?
Because apparently, if you try to, like, I'm not going into dad, my hand will not go into dad, but if I had like a knife,
yeah, that's it.
it would go straight in, because it's pointy.
So it's easy to remember that way.
It's me stabbing my dad, versus me just pushing with my hand.
So that's why you hear this chuck, it's called an auto chuck. There are a variety of different chucks. One chuck will hold a drill bit that has a point on it.
It's better for being pushed up into, and there are other ones for end mills.
So they have different size holes in them depending on how large your bit is, okay?
Yeah.
You'll get help from a mentor if you need to change that out. But the auto chuck allows you to push
do
the
it
chuck into the machine and then it'll
really
automatically
quickly and
suck it in
happily.
and grab it.
Okay, then I would go to the digital readout and zero my axes. I would make it so I would want to where I want to have my X and my Y, because this whole bottom part actually can move around like this and this. So that's how you're gonna take material off horizontally. You're gonna move the metal into the piece and then move it around to take the area that we need. So yeah, you can zero them on this, which is like setting a point where it's basically 0. And then it will reference all distances moved from the point that you've defined as 0. So that's pretty cool. Let me go back one.
So let me just kind of demonstrate what Tyler was just talking about. Say here's the chuck, okay, the bit. So what you do is you use your, we'll talk about this in a moment, but use your X and Y adjustments to get it so it's right there, okay? Right on the edge of the aluminum. So you're going to cut. So what you do is you go to the digital readout, which we can't see right now.
Okay. Yeah. There you go.
Okay,
Here's the
there you
digital
go.
readout.
There's a button they call, there's an X0 and a Y0, depending on which way you're looking at it or which way you're trying to zero it. Get it right to the piece of metal that you're going to cut. And you hit X0, for example. Well, now the machine is referenced, so if you go 0.25 forward, okay, it's going to cut into it 1/4 of an inch, and so on.
Yeah, and
so
then
you'll
it will
know
go
exactly.
right.
So you can, once you set 0, you'll know basically anywhere you go on this x-axis where you are, like 1.25 or something like that. And so it's really nice because in 3 dimensions, right? You'll zero your x and y axis, right? So if you go, 1/2 inch this way on the x, and you zeroed it on the y, you go 1/2 inch this way, and you'll end up with this nice little cut in the top of your dice, or whatever you want to call it. You cut into this piece of aluminum. So that's kind of how you go about it. Using the 0, either on a face or in a corner, okay? You can set that up so you can use your digital readout, zero your digital readout at this point, and you'll always know how far you traveled in one direction or the other, X or Y. Okay?
Oh, and to control how these move, you rotate these wheels. This one controls the x-axis. This one controls the y-axis. So yeah.
So yeah.
What you can tell is if you were standing, here's the table, or here's the table, and I'm at the mill. If I want to make it go this way, I'd rotate this wheel. And if I want to make it go like this way, I'd rotate this wheel. Actually, it'd go more like that.
Yeah.
So it follows it. It's actually on the table, so you're moving like your arm moves across. Okay.
Yeah, and an easy way to remember it, this has got a little handle on it, and so you can think about it, and then if you jammed up against you, you're like, oh, why did I just get hurt? Because you got hit by the Y handle, okay? And,
What?
It works for me. This handle
Oh,
sticks
wow,
out.
okay. Why did I get hurt?
Yeah, so if you step forward into the you get
That's worse than the other
stuck by a
part.
handle. Okay. See, now you remember it though. It's the scary part.
I remember it.
Okay.
Because it's
So
Why?
those are the things. So looking at this again. Here's the vise, right?
Here's a chuck here.
Here's the
That's
chuck.
what a chuck looks like.
The chuck. It holds the bit.
There are
And
different
then,
kinds of
and then
chucks.
this is the vise handle. Okay. That's the thing you crank to open and close the jaws of the vise.
Yes.
Okay, so for the bit, are we using diamond dusted tips?
Nah, tungsten carbide.
Oh, okay.
We actually cut one of the blades. Cut one of the things at once using a diamond grit sawzall. It took about an hour or an hour and 45 minutes. I'm sorry, but yeah. So these we haven't had any of them snap or break. We've only had like aluminum melt to it because someone wasn't using enough lube from the lube can that comes out the lube tube. Okay. This is the feed lever up here. This lever.
What does that do?
It makes this go up and down. It feeds the metal into the part.
So it
Or
happens.
the
as you-
aluminum, the cutter into the part.
So when you're standing in front of the mill, this thing pulls toward you like that to drop the
You pull it like this,
So
and then
it
it goes
pushes the
down.
chuck down into the work, okay? And then you let go slowly, and it'll pull up, okay? And the idea behind that is if you got hurt or something, you had to let go, but get out of your way in a big hurry. But usually just nice and smooth into the work, nice and smooth.
These don't
out.
retract.
Pardon me?
These don't retract.
That one doesn't?
No, the mills don't. Only
Oh,
the
okay.
drill press does, because these ones can get locked down.
Oh, yeah, you
Yeah,
lock
for
down. Right.
facing.
Wait, okay, yeah.
On the drill press, they retract automatically, and you don't want to
Yeah.
let them go.
But I think if you're doing the Y and you don't lock it down, I think it does go back up. Okay. All right. You don't- I guess that's not a question anyway, so you.
It isn't,
follow
but
that.
yes. Hit up. Come on. Okay, so up here we have the power switch. It's a switch that can go either up or down, which is the high or low range. The high range is where it spins faster, and the low range where it spins slower. Right here you've got the speed control wheel. You've got a tortoise and a bunny. Hairs are overrated. So you spin this wheel, and there will be numbers that appear in these little boxes that are for the high and low range, and this is how you define speed. What was the speed that we normally use for our one? Like
12 to
1300?
1600.
12 to 16? So apparently between 12 and 1600 revolutions per minute is the right number. So that's pretty fast.
So this power switch, I think Tyler mentioned that it's also speed control. So in one direction it's slow, and the other direction it's fast.
Yeah.
Okay. And they kind of
And
hit
here's
that off.
the feed lever on this one. Here's the chuck switch, and here's the readout. We have two different mills that we generally use. One is a bit smarter than the other. Chuck, there's a loop tube. These aren't on the test, but they're very important to know.
Yeah.
These are the axis locks. One of these locks the X, and one of these locks the Y, so it won't move. I can't remember which one, because they look exactly the same. One's on the left and one's on the right. So you experiment with it and find out which one is which.
Yeah.
While it's off. While it's not, while the mill isn't running and cutting your part.
Tyler, you're talking about the air guns?
Oh, yeah, these are air guns. They go. Psh. Have you ever played with canned air? They just make air go really fast and blow off like aluminum shavings to make it easier to work with. Oh, okay. So another thing we have is the parallel bars, which are, if you can kind of see, there's like a tier in the vise, or that the parallel bars help to. Yeah, you can draw this. You can elevate where the part is in the vise, because the vise is big, heavy, and expensive. So we want to not mill into the vise. So what we do is we place the parallel bars in the bottom to raise it up.
So yeah, you can kind of follow this drawing at all. Here's the vise right here, and the piece of aluminum is set all the way down into this bottom of the vise. It wouldn't be tall enough. It's tall enough, but it wouldn't be tall enough for the mill to come in, kind of make the cut that you wanted to, for example. Okay?
Yeah.
And so you'd use these parallel bars to basically lift it off the bottom of the vise by a certain amount. And they come in different heights, everywhere from like a quarter of an inch to probably an inch and a half. But they lift it high enough to get it off the bottom, but the vise can still have enough area to grab on the piece of aluminum so that it's secure in the vise. The big thing about the mill is you really want to secure your piece of aluminum. You really need to have it secured, because it's going to do a couple things for you. One thing is if it moves around at all, then that precision is just out the window in a heartbeat. I mean, you might as well, using a bandsaw if it's moving around, right? So the other part of it too, if it hops around while it's in there, it could fly out, which is a big time safety problem. So make sure that your work is secure in that vise when you're cutting. Because the idea is the mill.
Make it nice and happy and precise.
The mill is set up to move in every axis, right, around your piece of work, right, around your project. You don't want that moving at all, because for all the obvious reasons I just stated. Okay. Is there anything else
we need to go over something.
we We talked a little bit about.
different ways to keep it into the device.
Oh,
What else? You could lock the Z, which is there's a hit down. Right about here, there's a thing that can lock the Z axis, which is up and down. So that's another way to not mill into the device.
the device is really expensive. And
I said that.
It's part of the tool. And
It's expensive and heavy, and you don't want to break it.
the reason I'm emphasizing this is this question about it. Anyway, so a couple ways to avoid damaging the device is to use these parallel bars, okay? And then lock the Z-axis.
Why you don't get?
I know.
And then another
I'm
way.
taking a chance.
I actually don't know of any other ways.
No, it's not.
Do you know of any other ways, Ryan?
Like,
Be-
pay attention
Yeah,
to what
be
you're
very
at.
be very observant. If it looks really close to the device, change your parallel bars out and get higher.
Yeah.
And one thing we did some training last week on this in the mill, and when you zero out your part and you get it all, you think, I'm just going to make this cut and it's going to be great. It's really easy to just focus on the digital readout. You're like, I'm going a 1/4 inch or I'm going a 1/2 inch, and you turn your x-axis and you're starting to move it. Well, if you're not paying attention also to what's going on here, a lot of you could go cut into the vise. Your project could be jumping around. Okay, could be secure. Or something even worse could happen. So you want to make sure that you can watch the digital readout for where you are as far as moving the mill, but you also need to really keep an eye on what's going on with what you're trying to mill too. So you kind of have to focus on back and forth between the two. Didn't really talk about rate of speed for the cutters and then.
You can probably just do that at the actual shop. That's because you don't change that.
No.
Okay,
Not
it's
much.
still two.
But
Then
yeah.
I think okay. I'm gonna point at stuff. Let's open up the picture. All right. Pass it over again. Does that make it over here? Oh.
Oh, yeah.
Oh, hey, one more thing is these, fast spinning tools do have a tendency to get pretty hot. So if you're
Hot is bad.
making a long cut or something. So the last thing you want to do is assume that things are nice and cool when you're done milling. So just assume everything's hot when you get done, and a piece of metal that you're cutting, and especially the drill, the bit, okay? Because if you decide to take it out of the chuck and all of a sudden you've got it in your hands and it's burning you, it's too late at that point. So you're really careful.
Burning
The other thing-
death is not fun.
The other thing too is that there are sharp aluminum chips going everywhere when you're cutting. They just go everywhere. And so, you need your safety glasses on, right? But it's a huge temptation at times to grab these little chips, these little bits of aluminum.
Because they're sparkly and shiny.
Yeah, because they're freshly cut. And they're extremely sharp. Extremely sharp. It's so easy to cut. Even if you set your hand down, and there happen to be some there, you can get
Blood everywhere.
You can get cut. It's really easy. So be really conscious of what you're touching. How sharp those little things are, and then also you kind of have to assume that everything's going to get a little bit hot. So you don't want to just cut something and then immediately start removing parts like the bit off of the mill.
Okay, so what's this?
So why?
What's that?
Can't really see it.
Device lever, yeah.
Device lever.
What's that?
Device.
What's that?
Chuck.
What's that?
The feed button.
That's a chuck.
Is that the off-on?
This is the auto chuck.
The auto chuck.
The on-off is here. What is that?
Speed control.
Speed control.
What's that?
Feed out.
What's this? It's pointing at this lever.
Z-axis lock.
Feed lever.
Feed
What?
loader.
It's the feed loader.
Fine.
It does the
Sorry,
feed
sorry.
loader. What's this?
Okay.
This thing here, this thing that's going down.
I think I can totally not see. You can't really see.
YouTube?
Tube. What's that?
Tube can.
And this is.
X-axis.
Good work.
You didn't even do
The lube.
You should go do it again.
Nah, there's less.
Yeah, there's a lot. It's significantly less.
There used to be something pointing at this thing.
Which is like, what is it? Yeah.
It's just a truck.
No one knew what that was.
No, I didn't even know what it was. And it's a lamp.
Yeah.
So yeah, so let's take this test now.
Let's not. Let's start over.
So the last thing that
This is a slightly
I
better
really didn't
picture.
talk about this too much, but it's fairly intuitive. The harder material that you're going to be using, like if you're using steel rather than aluminum, or wood rather than, you won't be using wood for this, but wood rather than aluminum.
Actually,
The harder the
probably not.
material, the slower you need to go. Okay? In general, the slower you need to go. So if you decide to go really fast through steel, it could cause everything's going to get hotter quicker. Okay? That's a good the bits are very expensive, and you could actually burn up a bit if you decide to get too
Oh,
aggressive.
we're showing that video that comes off supposed to.
No, don't.
The mill horror.
I can't
So
take
yeah,
it.
so
Not watching it.
so depending on what you're cutting, really determines the feed rate. You're talking about the feed lever, right? Something goes down. If
This
you're-
one.
Yeah, if you're cutting into something fairly soft, you can go faster. And if you're cutting into something that's really hard, you can go a lot slower. And you can kind of get a feel for it too. You can kind of watch it and think, well, this seems like a reasonable rate. It's going into it. It's not pushing back too much. Not taking too much effort to put in there. That's probably, that's probably good. I don't think you really can go too slow on these things. I was there just the other day.
Yeah, you really can.
I was just going like an inchworm and stuff, and it felt good, and it gives it a nice edge too. But it does come out. It does come out of the mill really sharp.
How do you make a move? Yeah.
I think I have to be more specific than that.
Yeah.
You're gonna be more specific than first law.
Okay, so we're gonna hand out the test rather than wasting more of your time. Tyler, where are they?
Oh, you guys.
What? Coffee? Okay, I'll find it.
Tyler?
What?
Alright, we don't want to waste time. And also,
We're done. They can get this while I do this.
No, I don't want you to do
Okay,
this.
fine.
I don't know.
I don't know. I don't know if this, oh, probably is.
And guys, one of the two mills that we have can be programmed to like make different cuts that you probably can't make this like with manual precision.
Well, you could. You just.
Or be
You
very,
don't
very
want to.
Yeah.
It takes forever.
So like you'll be learning about how to like program the mill as well. Maybe it takes a while to learn.
Okay. I'm gonna split it, guys.